This is John Black, Super Chemist. I'm here to do a once in a while video about how I think or how my processing is. Working with permanganate, that's something new for me. I've only had little small quantities you make, learning general chemistry. Alright, I got paper, methanol, ethanol. There's my potassium permanganate. You can put a drop of paper, water. Oh, it'll catch on fire. Methanol. Ethanol. Yeah. So you can see if you don't put any acid in, it really doesn't do much. That methanol and ethanol just, did nothing. Maybe if you heat it up. Alright, let's try this with some acidified permanganate. This is ethanol. And don't do much. Actually, no, this is methanol. That don't seem to do much. Some paper. Sugar. Huh. This here is the ethanol. This here is the methanol. You can see it's no longer pink. It's orange. And this is starting to get like there's a precip in it. That's after about 5 minutes. This one has water. This one, well, they both have water because it's dilute permanganate. But you can see that it is doing something just by mixing it together. The acid really works. I wonder why this is orange though. What made it orange? What is orange? I can see it going pink, black, purple, orange. I don't get that color. Even green I could understand because of manganate. Orange? Why is it orange? And after about 5 minutes you can see the sugar, it's turning the permanganate solution like an orange on the edges. You can see on the edges of that pile of liquid. So it's doing what the ethanol is doing. It's turning it orange. So I added some more alcohol to these. This is ethanol. It's still just I don't get that orange. There's no precip. That makes no sense whatsoever to me. Where's the MnO2? Like here, I put more methanol in here. You can see there's precip. It's actually turning orange too, but I could see precip coming out, just like in all my other examples that I do. This one, for some reason, is not giving me a precip. Why is that? Why is it orange? Where does orange come from? After about 20 minutes, it's all orange now, that sugar. I don't know if the deal is with the orange, and I can see some precip coming out a little bit. Probably can't make it out on tape. As soon as I started shaking it, I could see more precip coming out. Now you can't make it out. This ethanol here, when it turned a little slight green, and now it's turning clear. This methanol is still doing what it should do. Both cups, you take a smell of it, they smell like acetaldehyde. Actually, just this one. The ethanol smells like acetaldehyde. Methanol, I don't know, maybe it's formaldehyde, I don't know. And you can see that this is the ethanol. This is the methanol. This is totally clear now. But what's funny is I don't see any precip in it. There's no precip at all. I mean, I'm sure there's something in there. I just can't see it. But this has a, I could see this precip. I mean, what's the deal with that? So anyways, the orange, I bet the orange is a combination of two things. This is just a guess. But think about it. If the purple, let's say purple permanganate is reduced to green manganate, it makes green. And plus you have the black precip. Even if you can't see the precip, there's fine precip there, I'm sure. You know what I mean? And it messes with the color. But if I put the exact ratio you needed in, I mean, I just dump stuff in. But I got lucky, I think, and it made exactly enough of the green, exactly enough of the purple, and a little bit of precip in there that you can't see, and that made it orange. You know what I mean? The combination of those three things. That's just a guess. I don't know. But this, I don't understand why there's no precip. I want to add some more ethanol. See what happens. This ethanol right here, I filtered it, okay? And there's no precip at all. None. That's the filter. There's nothing on there. Let me tell you. And it may have a slight pink to it. The only thing I can think is MNO, I mean, MN2, MN plus 2 state that it got reduced to. And you really need a lot of MN salt, MN plus 2 salt to make it pink, you know what I mean? You can put a little bit in there and you'll never notice it. But it could be my imagination that it's pink. Could be clear, you know what I mean? I'm thinking it's got pink because I want it to. But the whole deal is where did the MnO2 go to? If it didn't turn into Mn plus 2, where's it at? Let's put some more permanganate in there, acidified permanganate. Give it some time. I do have a third alcohol. These are the only 3 alcohols I got. Might as well try it in this.
70% rubbing alcohol.
Shaking and stirring it really speeds things up. Nothing's really happening. Let's give it a while and I'll let you know. Alright, so it's been a little while later and it did what it's supposed to. I could see that it's pre-sipping. It's turning a little orange. It's probably clear though. That orange, I guess, is just a MnO2 being dispersed or whatever, you know, through the water. It looks orangish. But anyways, alright, now I got some methanol in there. I'm going to add some acidified permanganate. Nothing really happens because it takes a while. But let's pour some concentrated acid in there, some sulfuric. Oh, Jesus. Wow. Well, that works a lot quicker. Jeez, it's hot too. What's funny is that's turning clear too. It looks pinkish though right now. Let's give it some time. I don't see any precip. Alright, I gave up on the ethanol having a precip, so I didn't film it. But I was like, screw it, I'll just throw a little bit more in there of the acidified permanganate. And it's starting to precip finally. So, I don't know why it took so long. Anyone knows, let me know. Always remember, science is great. Alright, now I got 2 containers there. The one on this side right here, that is acidified permanganate. This right here, that is just permanganate, okay? They both have alcohol in there. I just put them in there and I put them on my radiator, okay? The one that's acidified, it worked 2-3 times faster than the one that was not acidified. And you can see how it's actually super clear. Everything already went to the bottom. But this is actually working too, because you can see this top layer, it's dirty because it took longer, so it's still got the precip all through the liquid. But you can see it's working just as well. If I left it there, I'd probably go to completion, obviously. Uh, so this proves that they both work. Even the aqueous permanganate, even though there's no acid in there, it still works. It's just weaker. It's a weaker oxidant, okay? I don't really have any equations for permanganate in my notes. I mean, I have about 5 or 6 of them, but they're equations that are kind of generic, you know what I mean? It doesn't, I mean, I have examples of, you can use sodium hydroxide, make it alkaline and cold, like Ferris reagent. But I mean, they're all generic formulas, you know what I'm saying? So I did look in the internet, and this top one is what I found, okay? I don't know if it's right or not, but that's what I found. So I'm going by it. You can see on the right here, you're actually making potassium hydroxide and you're making your acetic acid, right? Those two things are going to react. So if you look down here on the left bottom, you'll see what you actually will have is 3 salt molecules of potassium acetate. You'll be left with 1 mole of potassium hydroxide, right? Then you'll have 3 moles of water, because that's an acid-base reaction, which gives you salt water. So you get 3 molecules of water plus your original water molecule from up here makes 4 water molecules. So anyways, you'll have a lot of salt there. Most likely I will recrystallize that out, and then I can, drip sulfuric acid on it to make, ethanoic acid, acetic acid. Now the second equation I just made that up because I'm taking it from this first equation. I figure if the top equation is a double oxidation, because you're oxidizing it to an aldehyde and then the aldehyde to the carboxylic acid. So that's 2 oxidations. I'm only doing 1 oxidation on a secondary alcohol, right? So I just took half of everything. I so I need half the oxidizer, right? That means I should get half of this, 2 of these, 2 of these, and a half of a H2. So really all these need doubled if you wanted to have this to be a 1. Now the third equation I made up 2, okay, because I'm taking it from the first equation, and the reason I put 2 sulfuric acid things on there is because look down here at this permanganic acid. Look at the formula. It's HMnO4. Okay, yeah, that means I need 1 H for every MnO4. There's 4 MnO4s over there, and 2 times 2 on the H's, so there's 4 H's. In my mind, an acid is an oxidizer, and that's what we're doing. We're making permanganic acid. Because you're going to have 2 protons in solution, and you're going to have 4 protons in solution, and you're going to have 4 MnO4 anions in solution. So isn't that the definition of permanganic acid? So that's how I got the 2 H2SO4 molecules in there. That was my thinking. Oh, now look at the end here, though. You're making something different. I mean, you're still making the same thing, right? But because of this sulfuric acid, it's going to be in the equation too. Now, instead of this reacting, even if it does, this will just change it back to an acid anyway. So these 2 are going to react. They're going to make 2 potassium sulfates and 4 waters, plus your original water. The MnO2 you can just filter out. And you're going to be left with 3 acetic acid molecules. You're going to have all acetic acid. It's not going to be a salt anymore. So on that one, I'll probably distill it out. And also, you're going to have your byproduct, the aldehyde. Always remember, science is great.